Good evening, everyone. Hang tight as we will start the workshop in 5 minutes. Good evening, ladies and gentlemen. Welcome to the first workshop of IntelliHack 3.0, organized by the IEEE Computer Society Student Branch Chapter of UCSC. I am Benidharatna and I will be your host for the evening. IntelliHack has undoubtedly become one of the most anticipated events in the ML community, bringing together talented individuals from around the country to collaborate, learn, and showcase their skills. It is a great accomplishment that IntelliHack is now in its third year as IntelliHack 3.0, being a testament to the passion and commitment of everyone involved. What makes this event ever more appealing is that you will get to put your skills to the test and be recognized and rewarded for your achievements. To tell you more about this and to welcome you all, it is my pleasure to invite the event chair of IntelliHack 3.0, Kavishka Fernando.
Good afternoon, everyone. Thank you for joining us with the first workshop of IntelliHack 3.0. I'm honored to be here today as we shed light on this exciting event organized by the IEEE Computer Society Student Branch Chapter of UCSC. IntelliHack is a machine learning hackathon that provides a platform for university undergraduates to showcase their skills and bring their innovative ideas for life. It is an opportunity for individuals to work together, collaborate, and build something truly amazing in a short span of time. First of all, I would like to give a brief introduction about the IEEE Computer Society Student Branch Chapter of UCSC. It serves the computing community as a source of technical information, community services, and individualized assistance. The CS chapter has been formed with the participation and contribution of all 4 batches of University of Colombo School of Computing, and dedicates itself to enhance the professional development of the students by organizing many activities related to computing. Machine learning is an ever-evolving field, and it is exciting to see how it can be used to solve real-world problems and make our lives better. This event is not just about building amazing projects. It's also about learning, networking, and having fun. Our participants will have the opportunity to be evaluated by industry experts, learn from the event, and engage in thought-provoking and insightful workshops. I encourage everyone to get involved in this event and take advantage of this unique opportunity, whether you are a seasoned veteran or a beginner. IntelliHack provides a platform for you to showcase your skills, learn new things, and be a part of a community of like-minded individuals. IntelliHack is a well-established event that has been around for several years. The event has also gained recognition from industry leaders and has attracted sponsorships from top tech companies and groups. This has helped bring additional resources and support to the event, allowing it to continue to grow and provide a valuable experience for participants. IntelliHack 2019, Sri Lanka's first ever machine learning hackathon, was our beginning. Starting from it, we took our second step, IntelliHack 2.0, last year. The 2 events received island level recognition, gaining a remarkable appreciation to our university, providing each participant a chance to showcase their skills and advance into a new era of machine learning. I hope you guys are excited about IntelliHack 3.0. I'm going to brief about the timeline. Today, we will have the first workshop regarding deployment of ML models on cloud-based application. So proposal submission will be open on 17th February. Workshop 2 will be held on 25th February on topic deployment and orchestrate machine learning pipelines with Azure. Proposal submission will be closed on March 11th. So the first round of IntelliHack is an ideathon where participants can pitch their ideas and form teams. During this round, 10 teams will be selected on the potential of their ideas and feasibility of their implementation. After evaluating all submissions, first round winners will be announced on 25th of March. On the same day, final round will begin. Once the team have been selected, they will be given a month to work on their projects and implement their system. You will have more than 1 month period to implement your systems. Here we prioritize on implementing your application. And the final round will be end on 6th of May. Finally, the event will be culminate in a 24-hour hackathon where the teams will showcase their completed projects to a panel of judges and an audience of attendees. This is a great opportunity for the team to demonstrate their full potential of their ideas and receive feedback from experts in the field. We will be informing how the 24-hour hackathon will take place with details in time to come after a discussion with our panel of expertise. The ideathon and hackathon format provides a comprehensive and well-rounded experience for participants, as it's not allows for ideation and collaboration, but also provide necessary time and resources to bring their ideas to fruition. I hope this explanation provides a clear understanding of the structure of IntelliHack. Good luck to all the participants, and I look forward to see amazing projects that will come out of this event. Thank you.
Thank you, Kavishka. So as Kavishka mentioned, today's workshop is based on deployment of machine learning models on cloud-based applications. You will learn tips and best practices on advancing ML and how to make the most out of cloud resources to deploy your models. We will also be posting a link in the chat, so you can drop any questions you have or any questions you encounter in the link that will be posted in the chat, and we'll be answering them at the end of the session. All right. I am thrilled to announce our guest speaker of the workshop of IntelliHack 3.0, Mr. Suresh Peiris. Mr. Suresh is a true inspiration in the field of machine learning with a wealth of experience in developing and implementing cutting-edge solutions as a director at Inforwaves and also as a GDG Sri Lanka Organizer. So without further ado, please join me with a virtual round of applause in welcoming Mr. Suresh Peiris to the session. Mr. Suresh, over to you.
Hi. So first of all, thank you very much, IEEE branch of UCC for having me in the session. And yeah, so like she mentioned, I'm Suresh Peiris. I'm one of the organizers of GDG Sri Lanka, as well as I'm a director of Inforwaves Private Limited, which is a product development agency. So today I'm here to discuss about how to deploy machine learning models on GCP or any other cloud provider. So during the session, I'll be mostly focusing on GCP. So if you have any questions related to that other cloud providers, you all are free to post your questions in the form that they have mentioned. So yeah, so without further ado, let's get started. Yeah, so I hope everyone can see my screen.
Yes, sir, we can see your screen.
Right. Okay. Right. So these are the topics that we'll be covering during the session. So we'll be, first of all, introducing the topic and some of the basics of deploy machine learning models on cloud and some of the principles. The second point, we'll be talking about how we can different types of testing and training environments for machine learning models. And next, we'll be discussing about how to build a machine learning model for those for the beginners. Actually, if you have no prior experience, you can learn about the basics from this point. And the next point, we'll be talking about some of the useful GCP products that's provided by the Google Cloud Platform. So these are some of the products that we'll be talking about: the Cloud Build, Cloud Run, Vertex AI, Compute Engine, and JK. And also, we'll be talking about how to deploy pre-trained models, and also we'll be talking about how to deploy deep learning models. And finally, we are doing Q&A, as well as we'll be talking about the conclusion. Yeah. So To introduce the topic for the day, we're talking about deploying machine learning. So when talking about machine learning models, there are two types of machine learning models. There are pre-trained models and there are models that we expect to train, right? So these are the two types of machine learning models that we'll be discussing over this presentation, over this workshop. We are giving step-by-step instructions on how you can deploy these machine learning models on cloud GCP. And to talk about machine learning models, and I think traditionally you all might deploy these machine learning models on compute instances, right? Or if you're using AWS, you all might use EC2 instances to deploy these machine learning models. So if you are a GCP user, you might use a compute instance or any other service to deploy these machine learning models. But there are better services offered by these cloud providers. There are serverless providers. There are serverless products. So these serverless products actually helps us to deploy these machine learning models with ease of use, and it reduces the number of lines of code that you have write when you are deploying these solutions on cloud. So we are talking about these serverless providers, serverless products that GCP offers, and we'll talk about some AWS products as well. And we are going to talk about the MLOps lifecycle. So if you have heard about MLOps, machine learning operations, so when it comes to the real industry, when you apply machine learning to the real industry, there's this concept called MLOps. It's actually a pipeline of gathering data to catering to large-scale applications. So we'll be talking about the MLOps life cycle that is being used in industry and how we could use these solutions, how we could use this to build your prototype to production grade. So yeah, so that's a nutshell on what we're going to discuss, and let's get further. Right. So if you're a beginner, if you're intermediate machine learning program, you all might be familiar with these environments, right? Sometimes some of you all might be already using local machines to train your models. Some of you all might be using cloud environments. So when it comes to local machines, you all might be familiar with these tools like Anaconda, JupyterLab, and you might be using a lot of software, lot of application, lot of services, right? So you all might be training with your IDs as well. If you have installed all the packages, you all might directly training models with your IDs, right? So those who are doing like scientific programming, you all might be familiar with these notebooks such as Anaconda, JupyterLab, and these actually provided. And when talking about virtual environments, you all might have heard about PIP virtual environment, ENV, and there are so many virtual environments provided by Python. So you will have to configure your machine to work with all of this, right? It's actually a huge process. Sometimes you all might have faced so many issues, you all might have faced so many errors when you're configuring your machine to train machine learning models. Also, to talk more about it, I think you all might, those who are doing like deep learning and stuff, you all might have faced when you had trained a huge, significant large model, you all might have to keep turning your computer turned on for a longer time. So in that case of scenario, it's kind of a hard task because there could be, especially these days, you know, the power cuts are happening, and you know, in Sri Lanka we don't get a constant power regulation, right? So in that sort of scenario, it's not easy to train large deep learning models in your local machines because you have to keep your machine turned on for a longer time. And also to talk about the hardware limitations, right? For an example, if you're training a large scale, let's say graphic model or like a, let's say a GAN model or a CNN model, you all might have faced the hardware limitations, right? Because you might need to have a really good GPU or CPU. So in that sort of scenario, you all might face, if you don't have enough requirement, the required hardware, you all might face difficult issues with these hardware required when it comes to training complex machine learning models. So those are some of the limitations that I see when we program in local environments. And this is where the cloud comes to play. So cloud is actually easy to use, and you know, it's cheaper, and there are some free providers as well, and it's fully cloud-based, and we can extend the hardware as you want, and it provides you hosted environments, and you don't have to worry about keeping your machine turned on for a longer time. So all these features are actually offered by cloud, And we'll anyway discuss about these features when you're doing a presentation. So those who are already familiar with cloud-based environments, you all might have used like cloud notebooks such as Google Colab, right? So Google Colab is one of the most famous cloud-based tool that most of the developers use nowadays. So that's one of the things I think you all might be familiar with Google Colab based. So this presentation, we are going to talk about more notebooks that we can use to train machine learning models. Hosted virtual environments. For an example, if you all are familiar with Docker and stuff, we can configure a virtual environment on cloud servers as well. And finally, like I mentioned earlier as well, we can extend the hardware use. So if you have any hardware limitations when you're training complex machine learning models, we can actually extend the hardware limitations by applying various of techniques. We can extend RAM usage, we can extend the memory, CPU, GPU, anything as per the requirement. So let's talk about how we can build a basic machine learning model. So these are the basic steps. I think most of you all might be familiar with these basic steps actually. So first of all, we are finding the source of data, right? So before we build the machine learning models, we have to find what sort of data we want. So if you are predicting the economy of Sri Lanka, for an example, if you're predicting the rupee for the next 6 months, I should have the forecast, I should have all the data sets for last 6 years, 6 to 7 years or 10 years maybe, right? So, and I might need various of economical factors to come to a decision, to predict the future, right? So that's actually a basic example. I think I can give better examples such as fuel price. For an example, if you're predicting fuel price, you need to have data sets of previous fuel price rates. So that's actually one thing. So when you come up with the machine learning project, first of all, you should identify what sort of data you want when you're predicting, when you're building a model and you're training a model, what sort of data you want and what sort of prediction you are doing. So if you don't have the right types of data, it's actually not easy to it's easy to train and it's easy to get accurate results. So in that case, first of all, you should decide upon the correct types of data that you are having in a machine learning model. And then the second step is that you need to code your model. So in a coding machine learning models, there are so many frameworks given nowadays. You don't have to code it from the scratch itself. If you're familiar with, there are so many frameworks such as TensorFlow, scikit-learn. It's a we get a library called scikit-learn, and there are so many other machine learning libraries. We can use one of these libraries, or we can use these frameworks to code a machine learning model. And for an example, if you have seen nowadays, there's this popular machine learning tool called ChatGPT. I think most of you are aware about ChatGPT, I guess. So even the GPT models are openly available nowadays. I recently saw an article published by the OpenAI, and I saw some of the GPT models you can freely use with OpenAI, and there are so many things that you could do. So you can check it out, those things as well, right? So that's about the coding part. So when you're coding machine learning models, you can use your favorite programming language. So preferably, I would always suggest using Python, because because most of these machine learning libraries are built for Python. So in that case, you can use Python, or you can use language like R. This language called R. So you can use R also. And the next step is that we should train the model, because we should train the model and we should get the model output. Okay, we should get the model artifacts. So when you're training, you should have the significant required hardware, and then we can do the training part, and then we should deploy the training model, right? Because training is not enough, right? Because we have to train the model, and in order to get the results, we should deploy that to endpoint. So those are doing machine learning offline. I think you all might have not faced this issue. So when you're deploying something, let's say if you're building a website or something like that, if you're building an application that uses a model to give predictions, you need to deploy that model to an endpoint. If you're building some sort of a full stack application or something like that, so you need to deploy that machine learning model to a workable HTTP endpoint. So that's a requirement, and that's the part that we are mostly focusing on during this presentation. And yeah, and the next phase is that we are getting the predictions. We are calling the endpoint and we are requesting for the predictions, and we are passing the data, and the model should give the expected output. And then we should monitor all the predictions, right? Because there could be accuracy issues, there could be so many other issues. For an example, if you're into deep learning and stuff, you all might have heard about this concept called hyperparameter tuning. So hyperparameter tuning is something like when you're giving predictions, you should constantly monitor machine learning model, and it should adjust the parameters. So basically, it's a huge concept. So basically, we should monitor the machine learning model in order to do like tuning and adjustments stuff. And finally, you can version your machine learning models and stuff. So we are not going to talk about those stuff in this presentation. So let's talk about the deployment part. So before going to deployment, let's see the benefits of having machine learning models on cloud. So most importantly, the cost benefit, right? So for an example, let's say, like I mentioned earlier, when you're training a model for like, let's say a graphic model, so you have to have significant required hardware, and it takes a long time to train such a model. And in that sort of scenario, you need to have you need to train those kind of models on cloud. So when compared to the energy factor and the cost factor, I would say in the cloud, it's more cheaper than training your machine learning models on your local machines, because you have to invest in your hardware and you're investing in the power as well. Because there are so many costs in terms of the energy factor and in terms of the cost factor. So you need to think about the cost efficiency. And also, no special expertise required. So when you're training ML models on your local machines, you all might have faced so many issues, because you have to set up your machine fully from the scratch. Like I mentioned earlier, you have to build your environment, you have to build install the required dependencies and libraries. So it requires significant amount of expertise, because when dealing with different TensorFlow versions also, I have seen, because when there's a new version, they introduce significant number of changes and new features. So I believe it requires a significant amount of expertise when you're deploying when you're setting up your machine for such a prediction. And also, in talking about the benefits of cloud, it's actually easy to scale up. And for an example, if you're building something complicated, you can easily add hardware, you can add GPUs, you can add memories and stuff, and you can scale up and scale down depending on your requirement. And when you're training something in your machine, it's not possible, right? Because you get the fixed set of hardware and fixed set of specification. So in that sort of scenario, it's not possible. So I would highly encourage to use cloud when you're training and testing machine learning models. So that's one of the benefits. And also the ease of integrations. So like I mentioned earlier, GCP provides wide range of products for machine learning model training, such as Vertex AI. You can even use services like Cloud Run to deploy your machine learning models. So these are actually serverless providers. So in that case, you don't have to worry about maintaining servers, maintaining complex backends and stuff, because these are serverless. You can directly deploy these your machine learning models to cloud, and you are free to watch, and you are free to call. You're free to call requests, API requests, and then it handles everything for you. And then it frees up resources. So if you all have heard about this concept for scaling up and down and horizontal and vertical scaling. So for an example, let's say if the system is not utilizing all the resources, it scales down automatically and it frees up the resources and it reduces cost as well, right? So these sort of scenarios we can automatically handle if you deploy machine learning models on cloud. And finally, the security and the privacy factor. Security is really great when it comes to these serverless providers. Right. So now let's see what GCP offers when you're training machine learning models. So these are some of the services that's offered by GCP. If you can see, it says ingest data, prepare, process. For all these steps, there are different products and services offered by GCP. For storing data, you can see there's a service called transfer service. There's a service called cloud storage service. And during this demo, also we'll be using the cloud storage service to set up your storage for machine learning model. And then to prepare the machine learning models, you can use any tech tool like Cloud Dataflow, BigQuery, or sometimes you might have to do data cleanup, right? On manual data cleanup. So those sort of process, you can use something like BigQuery. Or so these are some of the tools, and we will discuss that during our demonstration. So pre-processing also we can use BigQuery, Dataproc, Dataflow and stuff, and then Discovery, AI Hub, and yeah. So these are some of the tools. So when it comes to the deployment factor, we can use there are multiple tech tools offered by GCP, such as AI platform, which is known as the Vertex AI at the moment. We can use even Cloud Run. We can use there's a tool called Kubeflow. So all these things are possible with GCP. And so we'll talk about the difference between these products and which one to choose based on your specific requirement. And then talking about the workbenches, right? So I think some of you might be familiar with workbenches. You all might have worked with Jupyter Notebook, and Anaconda is actually provided by. You can get Jupyter when you install the Anaconda. And basically, you all might have worked with these workbenches, right? And Google Colab also, it's one of the workbenches. So AI platform, also known as the Vertex AI, has their own workbench that you can host on cloud, that you can deploy on cloud. So it's so easy because you don't have to worry about managing hardware. So you can define your own machine learning training environment, and then you can define your own workbench for training machine learning models and testing or doing whatever the experiments you want. So all these things are possible when it comes to GCP AI platform. And then repositories, AI Hub is there. So we'll talk about these things in the further slides. So this is the step that we are going to discuss today. It is a deployment step. Let's see how we can deploy. So these are the services that we'll be using to deploy this machine learning model: Cloud Run, Cloud Build, Cloud Storage, and Vertex AI. So we are doing 2 demonstrations today. And for pre-trained models and for deep learning containers, we'll discuss the difference later on. So when talking about Cloud Run is actually a content deployment platform. So I think if you're not familiar about containers, it's like an environment that we define to run a program in some sort of a computer or a server or any kind of a device, right? So basically, you all might have faced issues when you are defining machine learning models. There are specific environments that we have defined, because we had installed set of packages to work. So in those sort of scenarios, you have to make your own environment. And if you deploy your machine, if you deploy your application into some server, something like that, you have to set up the same environment in the particular server as well. To avoid that, you can containerize this machine learning application or whatever application you have, and then you can deploy that to a server. Basically, when talking about Cloud Run, it's actually a content orchestration. It's not orchestration; it's a content deployment platform, and it's fully serverless. And we can once we create a container, we can directly deploy your containers to Cloud Run. So yeah, Cloud Build. So in talking about Cloud Build, it's something like Docker. So basically, if you all have heard about Docker, it's a content orchestration platform. So Cloud Build is used. To create your Docker image. It's like contain images. So if you have a spec defined, you can define images. So if you're familiar with virtual machines, you all might have an idea about how the images things work. So there's a significant difference between virtual machines and containers. So this is not something like virtual machine. You can even have a container within a virtual machine as well. So we can use Cloud Build to make the image that we are deploying into Cloud Run. And the next thing, we have the cloud storage. Cloud storage is the service that we are using to deploy the produced machine learning model. So yeah, it's like a static bucket. So if you're familiar with AWS, in AWS you get the service called S3 bucket. So cloud storage is something like that we can store the machine learning artifacts on cloud. And yeah, we are using that as well. And finally, we have this platform called Vertex AI. It's actually the Google AI platform, previously known as Google AI platform, and now it's called Vertex AI. And there are so many features that comes with Vertex AI. We'll explore some of the features that comes with Vertex AI. And it has workbenches, it has training containers, it has data sets, it has auto ML features, and there are so many things to discuss when it comes to next year. We will discuss those during our demonstration. So yeah, so we are going to do 2 demos today, like I mentioned earlier. We are going to deploy a pre-trained model, and also we are going to deploy a deep learning container. So those who are beginners, I think it's easy to follow up with the first demonstration, which is deploying a pre-trained model. I think if you all have done ML before, you all might have pre-trained models in your local machines. So let's see how we can deploy a pre-trained model into cloud with Cloud Run. And finally, we have something called Kubeflow, which is actually industrial grade platform that is used for ML ops purposes. So yeah, so these are some of the all that we're going to discuss today. So we are going to discuss about how to deploy a pre-trained model, how to deploy a deep learning container to be train complex ML models. Yeah, so to talk about the workflow when you are deploying pre-trained models, this is the workflow that we should follow. So as you can see, we are inputting the source code from here, and you could have that in GitHub, or you can use your favorite version controller to store your source code. And then with Cloud Build, we are making an image, right? So we are making a Docker kind of an image. We are making a Docker image to deploy to the artifact registry. So artifact registry is something like Docker Hub. So if you're not familiar with Docker Hub, it's like a huge library of images. So if you can Google and find out it's popular. It's one of the most popular repositories called Docker Hub, which is a library of images. So basically, in GCP, they have their own private container registry called Google Container Registry. So you can actually, once you in the code build, you can build your image and you can push that to the Google Container Registry. And then once you have the image in Google Container Registry, we can push that particular image into Cloud Run, right? So once you deploy that image into Cloud Run, it serves with the API gateway and it accepts and it serves all the requests that the user sends. And when talking about the cloud build, we can use cloud storage to deploy the artifacts, and also we can use Vertex AI Workbench to do your training. And let's see how we can do that later on as well. And also one more thing, when you're serving ML models, you can always use cloud storage to store your ML models, the ML artifacts, because that could be changed at any time. So in that case, we can use we can have a connection in between Cloud Run and cloud storage as well. Right. So let's see what sort of prerequisites that we need to have in order to deploy something like that. So first of all, we need to have a Google account and Google Cloud account as well. And when it comes to Google Cloud, there are 2 subscriptions. You get the free trial and you get paid subscription as well. And you can subscribe to one of these packages and then get it. And when it comes to the free trial, they offer like $300 of credits of 3 months. So if you're signing up with your university account, you can get up to $400, I guess. And yeah, so you can subscribe to Google Cloud. And then you need to have your ML model, because like I mentioned earlier, we are deploying a pre-trained ML model to this platform. So anyway, I'll provide you with the required sources for a demonstration, and you can try it out at your own as well. And then we need to have your ID or whatever the notebook that you're using. That could be a Jupyter notebook, or that could be your own ID. So it's up to you. So it's actually optional. So as you can see, I marked that as optional because alternatively we can use a cloud hosted workbench as well. So yeah, so you can use you can always use the Vertex AI workbench as well. So you can use any of the workbenches that you prefer. And then you need to have an intermediate level of Python programming, because Python is a language that we are using for this demonstration. And yeah, and finally, your enthusiasm. It's the most important thing you need to have. So yeah, let's get to the demo. You all can access this link, and I hope the organizers would share this link with you all in chat. Can one of the organizers share this link as well? I'll share this chat. Yeah, so this takes to my GitHub repo that you can use, that you can find out the sample artifacts that I have deployed. So you can see there are two projects, which is called, there's one called Cloud Run and there's one called Vertex AI. So you can go to this Cloud Run and you can find the sources, and I have given some of the instructions. And let's see how we can deploy a pre-trained model. And let's see, let's first of all, let's understand the code that we have given here. So first of all, I'm using my cloud hosted workbench. So for this task, you can use your own ID or you can use your own workbench as well. But in this case, I'm using workbench that is hosted on cloud. Right. This is my environment, and if I open that, yeah. So first of all, you can see that I have this file called Docker file, which is used to containerize your entire application. And first of all, you can see I am having this environment called Python. As at the end, I'm deploying this machine learning model as a Python Flask model. So in that case, I'm using Python because Python is primary language here. And then I have an environment variable set up here to log messages immediately. And also I have this home environment, and then I'm setting up the work directory, and I'm copying the files, and I'm installing the requirements. And finally, I'm starting the application. I'm starting the application with this command. So if you guys don't have a basic understanding about Docker, that's totally fine. You can refer to some YouTube tutorials. There are so many tutorials when it comes to deployments and Docker and containerization and stuff. You can always refer to some of the tutorials that are available online. And yeah, you can get to know about Docker and stuff if you have no prior experience. So anyway, for the moment, you all can use the same file, and you all can understand what it does actually. So here, these are like set of instructions that you're giving when you're building the container image, and we are pushing that to the GCR, which is the Google Container Registry. So now let's have a look at the main.python file. So here, basically, this is actually a basic number recognition application. So you can see I have a pre-trained model here, which is in the H5 format. And it's a Keras model. I'm loading that from Keras. And then this is a pre-trained model. As you can see, this is a file. Then I have a transforming function, predict function. And at the end, you can see I have the functions that are related to Flask. I'm serving that in the root path. And then at the end, I'm starting the application. So these are actually Flask related stuff. I'm starting Flask application, and then I'm passing the arguments to the respective functions to get the predictions. So here, I'm directly getting the outputs from my model. As you can see, this is my machine learning model. And under these folders, you can find out the training scripts, the loading script, as well as the training script. So I'm not going to talk about the training part. I think it takes a significant time to explain a machine learning training part because it's a different topic, and I expect you all to have your own model to deploy. So in that case, I'll briefly go through this. First of all, I'm loading this model, and then calling the loss function and doing the training and fitting function. And at the end, I'm saving this model with this name called nn.h5. So basically, h5 is one of the formats that's used to store your ML models. So at the end, I'm doing a small evaluate and evaluating the model here, and then I'm getting the outputs of the evaluation as well. So these are actually the training script that you all don't have to worry much about it. So if you all have a background about machine learning models, you all might have an understanding on what it does. And yeah, so let's see what we can do now. Right, and this is a load file, and yeah. So talking about the requirements of txt file, this is something that's really important. So as you can see in the Docker file, we had a command to install the requirements, right? So when it comes to Python, when it comes to Python environments, you should have the requirements installed before you run an application. So there are so many dependencies that are required by TensorFlow. and especially when you're deploying an application, there are so many requirements that you should consider. So in this phase, in this code line, I'm installing all the requirements from the requirements.txt text file. So as you can see, I installed Flask, GUnicorn, TensorFlow, NumPy, and Pillow. Right. So it comes to GUnicorn is a library that you can use to manage Flask processes. So in that case, I would highly recommend you all install GUnicorn along with Flask, because GUnicorn is kind of a process manager Flask applications. So yeah, that's a bit about it. And now let's see how can we push this application to the Google Cloud Container Registry. So before doing that, there's additional step that you all have to follow. So there's this toolkit called G-Cloud CLI. It's actually the Cloud CLI toolkit. You can, if you're using your local machine to do this entire process, you can install this G-Cloud CLI from this URL, and you can choose the correct version for your machine, for your own machine. For macOS, Windows, it's available for macOS, Windows, yeah, so any other operating system, it's available. So depending on your operating system, you can download the correct version and you can configure with the steps they have given here. So they have given the steps for the installation, and you can set up the G-Cloud CLI if you're using your local machine. So if you use something like Google Vertex AI, the G-Cloud CLI comes with Google Vertex AI by default. So currently I'm using the Vertex AI workbench, and it comes with that also. So I don't have to install it separately. And I'm using a cloud workbench through the entire demonstration. So this is actually cloud workbench. So I'm using this to do the entire demonstration. All right. So now let's see the next process. So now we can open a new terminal. The terminal, you can, if you go to my README, you can find the assist function. There is this in step 5. It says G-Cloud build submit and tag GCR project name function. Let's copy and paste that. So now we should replace the project ID. We should replace the project ID with this, and then you can find the project ID. If you go to the Google Cloud Console, you can find it under here. You can find it under this. So this is the project ID. If you click on your project, you can find project ID from here. And then you can copy that. And ID is called workshop. And then I'm copying that project ID and replacing it over here. And then function name. So for the function name, you can give it any name you want. So I'm going to call it workshop main let's say 1. So it I should have the now let's try to exclude that. So now you can see the build process, right? So now you can see it's building the content, it's building the image, and it's automatically being pushed to the container registry of Google Cloud. So now you can see it's still building the image. It takes some time for the building process, and let's wait for a few seconds. So now you can see it's downloading all the required dependencies such as TensorFlow, and all the dependencies I have mentioned in my Docker file. It's running this command actually. It's running the pip install -r requirements command, and it's installing all the dependencies that are required. So yeah, so now all the dependencies are installed, I guess. Now it's running some command. Let's see. Let's wait for a few seconds and see what it does. Yeah, so it takes a few seconds. So until that happens, I'll show you what is the container registry of Google. So now you can go to your project under the Google Cloud Console, and you can search for container registry. You can go to this container registry. So under the container registry, you can see all your previous containers that you are deployed, that we have that you created. So this is a container that I created for the demo yesterday. And yeah, so now you can see it says pushed and it's still preparing the container. So once this process is done, your container should appear here. So this is a container that I deployed yesterday. It's called workshop 11. So now let's wait for a few seconds and see what it is. Yeah, so if you click on the container image, you can see there are multiple versions it supports. And in this one, you can see there's only one version. This is the one that I pushed yesterday. And if this takes some time, I'm going to use the same thing for my demonstration. So now let's assuming this is a model that I just deployed. This is a content that I just created. Now let's try to deploy the same image to Google Cloud Run. So yeah, so like I mentioned earlier, Cloud Run is actually serverless function provider, serverless content deployment provider that you can use to deploy containers as per your requirement. Let's go to Cloud Run. Yeah, so from here, you can click on create new service. Yeah, so from here, you can choose the container image. So now I'm going to choose my container image. That is the workshop 11, which I had deployed earlier. And then from here, you can give it a name. So I'm going to give it a name called workshop demo is something like this. Sorry, I'll call it workshop demo. It's called test. And then you can choose the region that you want to deploy. So there are so many regions that you can deploy these models into. So I'm choosing the US Central one region. And then you can configure the scaling part. So if you have a basic understanding about scaling, you all might know what is the minimum number of instances. Basically, when something scales up horizontally and vertically, you need to have a set of instances defined. So for an example, here I'm giving one instances. So for an example, if the instance one get the full traffic that it would have, it should create another replica of the same instance. So that's the basic principle of horizontal scaling. So depending on your capacity and depending on your budget, you can set the maximum number of instances that you could hold. So for the moment, I'm giving it 5 instances. That's more than enough because we are deploying a very basic application for testing purposes. It's not going to be a production grade application I'm deploying here. It's a very basic application. So I'm going to give it the maximum number of instances. Let's give it like 3. Yeah. So now it says authentication. So on the authentication, I'm going to allow all the unauthenticated invocations. So it's going to be deployed as public endpoint. So because of that, I'm going to call it allow unauthenticated invocations. So in the container port, you can define the container port that your Flask runs on. So usually Flask runs on 8080. So if you are using any other different port other than 8080, you can change that here. In some of the instances, you might have defined to run Flask on 5000 or 3000 or depending on your requirement. So you can define the container port in here. So in my requirement, I'm giving it 8080. Then if you have a specific arguments to pass to start the container, you can pass that from here as well. And here comes the most interesting part. So like I mentioned earlier, you can define your own hardware specification to deploy a machine learning model. Because there could be machine learning model that takes a significant number of resources and significant resource consumption. So in that case, you can define your own memory limits, CPU limits, and stuff. So here I'm defining like say 2 GB of RAM, and then you can define the CPU counter. So I'm going to need like 2 GB of RAM, and then 2 CPUs. You can define the request timeouts and stuff. And at the end, if you have any secrets like passwords or storing any passwords or any other information, you can define that as a secret, or you can even define environment variables as well. So now it's deployed that. So now you can see it says creating. Oh yeah. So meanwhile that we were doing that, you can see our previous content has been deployed. It says successfully deployed. And if you go to the container repository, it should come here. Let's refresh the page and see. If you refresh, let's see, you should be able to see the container that we just pushed. Yeah, here we go. So this is the container that we just pushed. It's called the workshop main. And you can see it's there, but we have already deployed the container, but that's fine. So now you can see it's setting up all the IAM roles and it's creating revisions and routing traffics. And yeah, so it takes some time until that happens. Let me explain you what this class process. So those who have done Python, I think you all might have already understanding about Python Flask. So it's actually a server. It makes your Python application a server, and it runs on a port, and you can define functions, and you can even do RESTful calls to your Python application. So if you have no knowledge about Flask, you can just go to Python documentation. It provides you a comprehensive guide about Flask and its use cases. So you can find the documentation here. If you want to know about basic use cases and the documentation, you can refer the Python Flask documentation. Right. So anyway, now let's have a look at the Cloud Run application. Now you can see it says creating revision and routing traffic. It says pending, and it takes a few minutes. So until that happens, I'll show you a previously deployed application. So now you can see this is an application I deployed yesterday, and it's called Index. Let's open that and see. Yeah. So this is actually an active application. You can see an application consists of a URL. It's the endpoint that you should call all the RESTful requests, right? So not only for machine learning models, you can use Cloud Run to deploy any kind of Flask application. You can use Cloud Run to deploy any kind of a Flask application. So this is the base URL of your endpoint up to API. You can copy that, and then let's see how we can make a basic REST API call and get the output, right? So now I'm opening my test directory, and the test directory. Yeah, so I'll close these for now. Test directory, you can see there's a file called test.py. So what it does is you can see it imports this library called requests. Basically, it's used to make Python requests. You can do like post requests, get requests, update, fetch, or whatever request you prefer. And here you can see I'm making a post request here to my base endpoint of this that I copied from my application, right? So it's the base endpoint of my application. And then I'm passing the image as a image file. So here I'm attaching image to my request, and then I'm attaching this image called 3. So you can see I'm actually doing a prediction of image to number conversion. So in that case, I'm passing this image of 3, and then you can see at the end I'm printing the response of this script of this model. So basically, the model is entirely hosted on Cloud Run right now, and I'm calling an HTTP request, RESTful request, and then I'm I'm sending the file as well, and then at the end, I'm printing the output of that particular model. Now let's see how we can get the output. So now I'm opening a terminal. Let's try to run this test application and see. So here you can see it gives me the prediction JSON format. It says prediction is correct. It's 3. It's not the number 3. So if you have a different output also, you can add in another image here, and you can see how the output comes. So now, right now, you can see it gives the correct prediction. It's calling it's calling a RESTful request, and then it comes to this application, and it sends you the request. So here you can view all the metrics such as the request counts, latencies, and you can monitor the entire state of the applications, and you can view all the statistics here in this dashboard. If you want to change anything, you can do that as well. If you go to this YAML file, you can configure your entire specification as per your requirement. You can even define security rules. So these are some complex configurations. So I'm not going to those things in detail. So it takes some time for the deployment. I think there's small error occurred. Let's see what's the error. Right, so now it says the user provided container failed to start and listen on the port 8080. Right, so that's because I already have another instance enabled. It says executing. Right, so this problem because I have another container running up. That's why I'm getting error. So I have to shut down one of the containers because it's using the same port to serve the traffic. So currently this one is running successfully. So you can see, so you can see it's currently running successfully, and you can see all the statistics over here. So that's a brief about how you can deploy a pre-trained model to GCP, and so let's see another example. So I hope you all have gotten a brief understanding about deploying a custom ML model, a pre-trained ML model. And if you're not familiar with this code, it's basically actually it's on training ML models and testing ML models. So you all need to be familiar with the basics of ML to be familiarized with this training model code. So yeah. That's about the first. That's about the first example that I have in hand, and I would like to mention one more thing. So I shown you how to do that process with Vertex AI Workbench, right? So this is a Vertex AI Workbench that I just used to do the entire demonstration. So if you are coding in your local machine, you can do that also. So here, basically, I had the Visual Studio Code, and then the entire code base is here. And you can, so if you have installed this Google Cloud CLI, you can run any of G Cloud commands in your local machine. So you can run this command as well, the one I just shown you, G Cloud build command. And you can execute these G Cloud commands if you have the G Cloud CLI installed in your local machine. So here also I have the Docker file and I have all the respective files. And then you don't really worry about installing Docker even. So in my machine, I don't have Docker also because I'm using the Google Cloud build to make Docker images. So I don't have to Docker in order to make Docker images and push to the container registry of Google, right? Because GCP, the cloud build handles that for you. So that's the biggest benefit that I see in Google Cloud build is most of machine doesn't support. You need to have a huge machine spec to support Docker to be building complex images and stuff. So GCP handles the entire process for you. Right. So I hope you all have basic understanding about deploying custom models now. Now let's see how we can do how we can deploy deep learning content. So before we move forward with that, are there any questions? Are there any questions from the audience? Let's see, moderator.
Yes, sir. I'll check.
Right. So Antish, yeah, you can interrupt me at any time. That's totally fine. So I'll proceed with the second part of the session as well. So I
Yes,
hope, yeah,
Um,
you all,
We'll
yeah.
take the questions at the end, sir.
If you have any questions right now, if you have gotten any questions, you can ask right now as to the exciting.
Okay, okay.
easier. Yes.
All right, okay.
Do you have any?
No, sir, nothing as of yet.
All right, right. So if you all have any questions, you all can send those questions in a Google form. We have the organizing committee has shared. So at the end of the session, we'll discuss those questions. Right. So now we just learned about how to deploy a pre-trained model to the GCP Google Cloud. Now let's talk about deep learning context. So those who are into deep learning, you all might have noticed that it takes a long time to train in your local machines, right? Because deep learning is not an easy task. It's actually a complex task that requires so much of resources. So you need to have a cloud server to run to train huge models. So now let's see how we can do that with Vertex AI. First of all, let's learn about Vertex AI and what it does. So Vertex AI is previously called as the Google's AI platform, and it's actually fully serverless. That means we don't have to set it up from the scratch itself, and it provides all the services that are required to train, test, deploy, and monitor these machine learning models. And then Vertex AI offers tooling support for advanced ML coding, and with less number of codes, you can easily deploy your machine learning models, and you can even monitor these machine learning models as per your requirement, as per your preference. So now, right, so I'm going to skip this video, and no, I will watch this video. Yeah. I hope my machine audio is audible. Let me quickly stop the screen share, and I'll. Is my machine audio audible?
Yes, sir, yeah, we can hear.
Hi everyone, I'm Sri Lanka and I'm going to show you Vertex AI training for model using code and container. We'll be using a data set of technical specs of automobile.
Excuse me, sir, now we can't hear it.
Sorry.
We could hear the audio earlier, but it's not audible.
Oh, right. Right. Let me stop the share once again. Can you hear now?
Model with description.
Yes, perfect. Thank you.
Okay.
Hi everyone, I'm Sri Lanka and I'm going to show you how you can use Vertex AI to train and serve a TensorFlow model using code in a custom container. We'll be using a data set of technical specs of automobiles to build a model that can predict the fuel efficiency of late 1970s and early 1980s cars. You can find this data set on Kaggle. We must provide the model with descriptions of several automobiles from that time period. The description includes attributes like cylinders, displacement, horsepower, and weight. We're working mainly in a notebook, so think of this as an interactive web tool where you can combine code, computational output, text, and multimedia resources in a single home. So we've set up a container in here, a portable environment for working with our model. Don't worry, we have all the source code and instructions for you in a code lab to try this out at home. So now that everything's set up in here, let's train the job on the platform. I can go here to the trainings tab, create new job, I'll name my demo, add a few other settings like our container URL and compute specs, and now it's off to the races. This one actually takes 10 to 15 minutes to train, so I ran a job ahead of time so we can test it out together. So now that it's trained, we deploy an endpoint and we can now use this back in our notebook. So now for the moment of truth. Let's predict a sample. I've added a cell down here with a sample case. So this is a set of attributes that we described earlier, but they've been normalized, which is why they don't look exactly like, say, a year or the weight of a car. I hit run, and we can see that an automobile with these values would give us approximately 16 miles per gallon. So to make this visual, I can use a lot of ready-to-go functionality to visualize my data down here. Use graphs and charts to share your findings with your friends. We hope we've inspired you to try working with your own data, or to recreate this demo, check out the links provided.
Right. So now you all saw a small intro about Vertex AI and some of the features that are there. And now let's talk about the ML of the machine learning life cycle. So I think by now in the earlier slides I mentioned about something called ML ops, which is the life cycle of machine learning. So when it comes to industry, this is actually industry practice as used in industry. It's called ML ops, and it's a process of managing the entire pipeline from data gathering to model management. As you can see, these are the steps that are involved when it comes to these are the steps that are involved in the ML life cycle. Reading, feature engineering, training, model serving, understanding, edge, model monitoring, and model management. So all these stuff are possible with Vertex AI. So I'm going to demonstrate some of the features that are there in Vertex AI. And also there's a concept called AutoML. Those who have heard about AutoML, it's actually an automated mechanism of classifying data and doing predictions. So there are video models, there are language models, there are transition models, and there are so many models. We'll see what these models and what are the capabilities that these models has. And yeah, so how does it work? So basically, like I mentioned earlier, so we are going to have the Vertex as a core platform, and you can have your own backend to proxy the request that's coming from Vertex AI, and then you can serve the traffic to your desktop clients and mobile clients as well. So depending on your requirement, you can serve this traffic to your desktop clients and mobile clients. Right. So these are some of the services that are provided by Vertex AI. And you can see AutoML, deep learning images, workbenches. The workbench is the one that I've been using throughout the previous demonstration. And we have something called matching engine, data labeling features. I think all this stuff are ML related and AutoML related. And we have explainable AI, and there are so many capabilities. I'm not going to talk about the entire thing. So we can explore all these things. All the documentations are provided. So if you go to this link, you can find out all the capabilities. So yeah, so let's see how we can automate your ML workflows with Vertex AI. And Vertex AI, it supports custom datasets. If you have custom datasets, you can upload that to the dataset section of Vertex AI, and it supports. And you can even upload classified data such as image datasets, forecasting, tabular datasets, like video datasets and stuff. If you have classified already, you can upload the dataset. With AutoML, you can get automated predictions, and you can make automated predictions with AutoML. And those are some of the capabilities that's there in Vertex AI. And for development, we have this workbench. I think I mentioned about this earlier as well. And for the training phase, we have custom training and AutoML. So if you have custom models like deep learning models and stuff, you can easily train Vertex AI. And when it comes to the deployment, we have the runtime containers, and we have, if you want to deploy a deep learning container, that's also possible. And with your own spec, you can define the container that you want to deploy. And then that's also possible with Vertex AI. And then finally, we have to expose the container as an endpoint, and that also we can definitely do. There are endpoints in Vertex AI, and we can directly expose these endpoints, and we can display the predictions that generated from the ML container. And also there's a Python SDK. So if you want to display these predictions, you can use Python SDK and show these predictions in your applications, and render these predictions in your applications And also there's a RESTful API provided. So if you're having a custom backend, if you're making RESTful calls, you can do that. Right. So datasets, there are two types of datasets that are given in Vertex AI. We have the managed datasets and we have custom datasets. So yeah, these are some of the benefits that are there in managed datasets. And comes to custom datasets, it also supports datasets hosted on other cloud providers such as AWS, BigQuery actually Google product. It supports some of the datasets hosted in S3 as well. And if you have a custom location, it supports custom locations as well. As long as you have the HTTP or HTTPS URL access, you can directly copy that dataset link and you can paste it on Vertex datasets and you can import that as a specified dataset. So these are some of the dataset type it supports, managed datasets. And you have images, text, tabular data, and video stuff. And yeah, so as you can see, talking about managed datasets, it's capable of doing so many types of classifications, such as image classifications, multi-labeling, object recognition, image segmentation. All these things are possible with the managed datasets. If you want to do a regression, so even for someone who does not have a bigger programming knowledge, you can get started with Vertex AI, and you can train your. If you have your dataset in hand, you can easily get predictions based on the criteria that you set. So it doesn't require any programming knowledge. So I'm talking about the managed datasets, right? And you can do text classifications, multi-labeling, entity extraction, sentimental analysis, and so many things are there. And we have video action recognition, video classification, and object tracking as well. And all these things are capable with the managed datasets of Vertex. So if you're advanced developer, you can import your custom dataset and you can write your own ML model and you can do even a complex prediction. So everything is possible. Right. So when talking about notebooks, we have managed notebooks and user managed notebooks. So Vertex AI provides you the capability of customizing your own notebook as well. So if you want to install a separate set of packages, if you want to install your own packages, you can do that also with the Vertex AI notebooks. So if you want more custom configurations, you can set up a user managed notebook with your own configuration, with your own system configuration. You can define the system RAM, memory, CPU usage, or all the parameters you can define. You can create your fully 100% customized notebook as per your requirements. Right. So these are some of the frameworks and libraries that are supported in managed notebooks. And yeah, so it supports frameworks like scikit-learn, Python, Keras, Anaconda, NVIDIA, Pandas, XGBoost, all like these are some of the frameworks that are supported. And you can always extend the capabilities. You can install custom libraries as well. So it's all possible. So you don't have to stick to these. Frameworks. You can use your own libraries. You can install your own frameworks depending on your requirements. All right. So I think I mentioned these earlier as well. These are some of the capabilities of AutoML, such as translation, text to speech, forecasting, classifications, and stuff. Right. So yeah. So there's something called pre-built containers. So there are two types of containers called training and testing containers. So when you're training, when you're training something like that, when you're training a model, there are two types of containers that you can use. You can use a pre-built container, or you can use your own container. So like I mentioned, if you have your own Docker, if you have deployed your own Docker image on Google Container Registry, you can deploy that particular container as a custom container. So if you don't have a custom container, that's totally fine. You can use a pre-built container to deploy a machine learning application on Vertex AI. So it supports all this stuff like TensorFlow, scikit-learn, PyTorch, XGBoost, CUDA. It supports multiple other frameworks also. So you can always use something like pre-built container to deploy. If you don't have an environment specified, you can use a pre-built container for this purpose. And also you can do hyperparameter tuning jobs. It's actually along with the deployment process, you have to monitor and do the parameter training. So it's a measure to improve the accuracy of the model. So you can do you can schedule hyperparameter training jobs as well. And then yeah, so also to talk about the deployment process of ML models, there are two types of ways that we can access the results of a deployed endpoint. So now, up to now, we learned up to deploying a custom container. And once you deploy a custom container, you can deploy an endpoint as well. And there are two types of methods that we can use to retrieve the results of the deployed container. So we can use the RESTful API, or we can use the Python SDK. So in the same way that we implemented in Cloud Run, you can use the REST API, or we can use the Python SDK to get the predictions from the model, from the endpoint that you have deployed on cloud. So this is actually sample API request. As you can see, we are calling a sample API request. We are passing project ID, and we are passing the endpoint ID, and we are passing the input data, and it gives you the output of that particular module. Right. So now let's see another example. Now let's try to explore code lab. So I'll share this link on chat. There's a code lab that is provided by Google. Yeah, so I'll share this link in the chat. So this exercise provides you a whole guide on how to deploy and how to explore Vertex AI and how to deploy your custom container, custom model on Vertex AI and get trained. So now let's go to Vertex AI and let's explore it a bit. So now in the first step, it's giving a basic overview. Then I think I discussed about these things earlier. Now let's see how we can configure the environment. Right. So first of all, I'll show you how to create your own workbench. Right. So first of all, go to the search and search for Vertex AI. Right. So once you search for it, you can see it takes you to the Google AI platform, which is now known as Vertex AI. And then from here, you can go to this section called Workbench. So in the Workbench, you can go to this, there's a section called User Managed Notebooks, right? There are multiple, as I mentioned in the presentation, there are managed notebooks and there are user managed notebooks. So from here, you can, depending on your requirement, you can choose either managed notebooks or user managed notebooks. So if you want any highly advanced configurations, such as advanced configurations or advanced customizations, you can click on user managed notebooks and you can create one. And here it gives you so many configurations like Python 3 environments, TensorFlow, PyTorch, R, CUDA. So you can choose, depending on your model, you can choose whatever the environment you want to train. So now I'm going to define TensorFlow Enterprise. And here I can choose the TensorFlow version. And you can, if you want GPUs, you can add a GPU as well. If I want to train a model at 2.5, I'm going to train a model without the GPU now. So I'm going to call it without GPUs, and you can give a name for the node. So I'm going to leave the same name, and then you can click on advanced options. Yeah, so from the advanced options, you can do so many customizations for the machine. And let's see, yeah, so you can choose your operating system. If you want Debian or Ubuntu, you're free to choose whatever spec you want. And you can choose the environment from here. And once you're done with it, you can click on machine configuration. The machine type, you can choose the machine type you prefer. So one vCPUs with 3.75 GB of RAM or two vCPUs with 7.4 GB of RAM. If you want high CPUs, you can choose whatever the preferred CPU. You can even go for very advanced configurations, can even use GPUs such as NVIDIA Tesla. So it's up to you. So depending on the scale of your ML model, you can choose the specification as per your requirement. So I'm going to give it a standard machine with 2 eCPUs and 7.5 GB of RAM. And then in the disk, you can give the storage. So the minimum storage is actually 100 GB, and you can define the required storage to store your machine data. And then you can see the monthly estimate for this. So if you're using the trial, the cloud trial, it won't be charged because they provide $300 of free credits for 3 months. So you can try out the entire platform for 3 months, and you can even complete the hackathon project during the evaluation period, I guess, because it provides you credits for 3 months actually. So with your university IDs, you can get additional $100 of credits as well. So altogether, you will get $400 of credits. So you're open to explore that. Right. So from networking, you can give advanced networking options, and once you're done with it, you can click on this create button. So I'm not going to click on create button because I already have workbench provision. So this is the workbench that I've been using for the whole time, and it's similar to it's actually powered by the Jupyter Lab. I think most of you are familiar with Jupyter Lab, I guess, because with Anaconda you get the Jupyter Lab installation. So yeah, that's about the workbench. And now let's see how we can train a custom model on Vertex AI. So now I'm going back to my code, and let's see. So now we have successfully configured the environment, and then I'm going to the next step. So now let's containerize the code. So before that, I'll show you a bit of my code that I share. So now you can go to the code. You can go to the folder called Vertex AI, and under the Vertex AI folder, you can see there are 2 folders, which is called test and trainer, and we have Docker file. So in the Docker file, you can see it uses this Google, the deep learning platform release, and TensorFlow 2.6 as the base content. And we have the entry point of this. So I'm using the train.py under the trainer package, right? So this is a file, the Python file I'm calling. So you all might have noticed a difference here. So earlier I did another exercise. In this one, I'm doing another. There's a small difference when compared to the previous example I did. So in the increment, you all might have noticed that in the previous example, I executed a Flask application, right? So earlier I executed Flask applications. So here I'm not executing any Flask application. Instead of that, I'm executing the training model, because this is actually for complicated ML models, such as if you're doing any sort of a deep learning training or any sort of a complicated training, ML training, you can use Vertex. This is the difference, right? So you can use a Cloud Run kind of thing for simple applications. But if you are deploying something like complicated, if it takes a long time to train, you can use Vertex here. The main purpose of Vertex here is to train models. So here, the entry point is the trainer. I'm calling this file. So I'm training this model, and here we have to do a small modification. The modification is that you can replace this. So here you can see there's a configuration called bucket, right? So what it does is basically, once you are done with the training, it stores the model artifacts in the Google Cloud Storage, right? So once you're done with the training, it stores all the artifacts in Google Cloud Storage. So I think I mentioned about the Google Cloud Storage platform as well. So if you go to here, if you go to Cloud Storage, you go to Cloud Storage, you can see that these are the Cloud Storage buckets that I've created. And the main purpose is that we can use these buckets to store the artifacts of the model, the output models that generates from the trainer script. And once we run that script on Vertex AI platform, so all the artifacts are stored in the bucket we defined here. So here we have a bucket called workshop 1 that I deployed yesterday. So if you go inside that bucket, you can see the files that are available inside it. See, these are the files, these are the model artifacts artifact files, right? So these are the model artifacts files. You can see these are actually Keras model. So you can see all the artifact files are there within the bucket. So now for this thing, you should have the bucket URL, bucket ID. Now you can see the bucket ID is called workshop dash and this value. We should have this value as the environment variable. So depending on your bucket name, bucket ID, you can replace this value with your configuration. So I'm going to leave it the same, and you can see loads the entire data set from an external URL, and it does some cleaning, and yeah, it does some cleaning, and at the end it does the fitting part. And then at the end, you can see that once you're done with the training, it saves this model in the particular bucket. See, bucket plus mpg/model. So if you go to the cloud storage, you can see there's a folder. The folder stuff is called mpg/model. So the bucket, the model is stored under this part, right? So the entire model is stored under this part. So once you're done with the training, it automatically stores the model in your artifact directory, right? So now let's see how we can schedule a training job. So to schedule a training job, you should go to the cloud platform, and then here you can go to Vertex here once again. Yeah, so from here you can go to there's a section called training. You can click on training. Under the training, you can go to custom jobs. So under the custom, so under the custom jobs, I can click on create. And you can give a name. So here I'm not defining a data set because the data set is already defined in the script, right? You can see the data set path is already given. So now we are supposed to deploy entire container. So because of that, I don't have to define data set. So in that case, I'm leaving it blank. Then click on continue, and you can give a model name for the model. I'll call it workshop demo model, and you can give a description also. And then if you have an advanced configuration service account, so if it accesses some of the third-party service of GCP, a service account would need it. But for now, I'm leaving it with default configuration. All right. So now, right. So now, like I mentioned earlier, we have our own container, right? Because we containerize the entire application, and we push that to the container registry, right? So in that case, sorry, I think I forgot to mention that part. So once you're done with the entire thing, you should push that to the container registry. So you can use the same command, and then you can push the image to the container registry of GCP. So as the same step I mentioned in the early exercise. So here we should define the model frame, the model container type. So here I'm using custom container, and then I'm defining that from here. So here I have 3 models. You can see I have the workshop main, workshop 1. I think this is the one I deployed with Vertex here. So I'm choosing this model. I'm choosing this container, and then you can choose a model output directory also. So currently I have this bucket. So I'm choosing the path of MPG. And then I'm going to continue. Then if you don't have any hyperparameter training jobs, you can just pass that also. And then for the training instance, you can always give a training instance configuration from here. So if a specific configuration requires a training model, you can configure that also. Depending on your model, you can at your own configuration. Before we say this, I'm going to get the lowest configuration. And finally, I can click on. So if there's no other configurations, I can, yeah, so here you can even choose the GPU if required. So if there's no other configurations, we can directly go ahead and we can, yeah, so there's one more thing I missed to explain. So here, there's something called prediction container. So currently we already defined the training container. And in order to get the results, we should define a prediction container, because usually the prediction is handled from the end of GCP, from the end of Vertex. So currently we haven't written any prediction scripts in my code. If you have seen, we only have the training script, right? We don't have any prediction script. So in that case, the entire prediction is handled through the end of Vertex. So in that case, I'm going to give it a configuration, pre-built container, and then you can choose the container framework, TensorFlow, and TensorFlow, you can choose a version of TensorFlow as well, depending on your requirement. And then model directory, I'm going to leave it the same. And once you define that, you can click on start training. Okay. So once you start the training, it schedules a training job, and it schedules a training job, and at the end, you will get the results. Right. So it takes, you can see, you can follow the exact same guidelines they have provided in this code lab. And at the end, you can see the status of your trained model in here. So now I'm going to click on start training. Right, so it should be here. It should be listed here. It takes some time to appear. I'll define that once again. Yeah, so I'll define the custom container once again. And the model output directory. I'm going to leave blank, and then once again, the machine type. Then the prediction container once again. Yeah, so it actually takes some time to populate this entire model, and currently it says, yeah, so it says an error. It says unable to start training due to the following error. The cloud storage bucket of GS is in location of US center, so it must be the same region as US West, right? So we have to do a small modification here. So if you go to the compute, you can see the storage bucket is in a different region, and my training container is in a different region. So it's the US West. So I should change this to US Center. Now let's see. Now you can see it, it starts once again. Yeah, so now you can see starting. The model has been created, and right. So this is the one I defined earlier, and you can see it says it has been successfully finished training. And if you go to the endpoints, right. So if you go to these endpoints, now we should now the next step would be deploy this model as an endpoint. So now if you go to training, you can see all the trained models are there, right? So these are the trained models. So one model is already trained, currently training, and this is a trained model that duplicated the same thing once again. And if you click here, you can see the statuses. You can even see other statuses of the model. So now the next step would be deploying an endpoint. So now you should go to this option called endpoints, and you can click on create endpoint. So for the endpoint name, you can give it an endpoint name. So I'm going to give it an endpoint name called sample EP1. And then you can choose the region, and you can define the access model. So if you want to make this endpoint private, you can do that also. And if you want to serve that as a public endpoint, you can do that also. So I'm going to click next, and you can add the model. So here's a model that I trained earlier. And then for the traffic split, you can leave 100% because I'm not going to do any scaling here. So I'm going to have only one node. In the one node, I'm going to allocate the entire 100% web traffic into my single node. So in that case, I don't have to define traffic split here. You can yeah. So it has right. So there are more configurations I need to explain. So here we should define the machine type. So for the endpoint, I am so here for this machine type, we don't have to have a huge configuration because this only does the prediction part, right? So we don't need to have a complex configuration because it does only the prediction, because we have already trained the model. It's already there in the artifacts. And for the training part, we can choose the machine configuration here, and then you can choose the service account, and then click on done. Right. So once you click on that, once you click on continue, we'll get to the last step that we should follow. Click on create. So then it creates the model for you. The endpoint for you. So now you can see it says deploying model, right? Now you can see the model is being deployed, and a new endpoint is being deployed, and we should be able to call API requests and get responses. So now let's see how we can do a small API call and get the responses. So this is actually example given on Google the TensorFlow documentation. This is actually a full price prediction model that I just deployed, and let's see how we can get the outputs. So now I'm going back to my workbench. Here I'm going to the testing part, right? So I have a testing script here. So what it does is I'm using the AI platform Python SDK, which is currently known as the Vertex AI Python SDK. And then I have defined the endpoint, right? So you can see an endpoint should consist of the project ID, and then it gives you the API response. And at the end, we are showing the accuracy levels of that particular model. So now let's try to run this script and see the output. Python, let's try the Python test. See, now you can see it gives you the output, right? So you can see API response, you can see the model ID is displayed, and the predicted output is given. So you can change any of these test data. And this is actually, like I mentioned earlier, this is actually a full price prediction model that I'm using for this demonstration. And so depending on your niche scenario, you can use any kind of model and you can deploy that with Vertex AI. And yeah, so I think that's a wrap. And yeah, so thank you very much.